Imagine standing hundreds of meters away from a building that's about to disappear. The countdown reaches 0. The explosives detonate. The ground shakes. A massive cloud of dust fills the air. And then, something impossible happens. The building is still standing. Controlled demolitions are among the most precisely planned engineering operations in the world. Every explosive charge is carefully calculated. Every collapse is modeled in advance. Yet even with months of preparation, thousands of tons of concrete and steel don't always behave the way engineers expect. In this countdown, you'll see 10 real demolitions that went terribly wrong. From buildings that refused to collapse, to structures that fell in the wrong direction, to implosions that forever changed demolition safety. Each incident became a powerful reminder that once gravity takes over, even the smallest miscalculation can have enormous consequences. Before we begin, tell us in the comments, which demolition do you think would be the most difficult to control? A skyscraper, a bridge, or a cooling tower? If you enjoy real engineering, incredible construction, and fascinating true stories caught on camera, please like this video, subscribe, and turn on notifications for more countdowns like this. Now, let's begin with number 10. Number 10. The cooling tower that refused to fall. Didcot Power Station, United Kingdom, 2020. For a controlled demolition, everything is supposed to happen in seconds. Months of planning, hundreds of calculations, carefully placed explosives. Then one press of a button, and thousands of tons of concrete disappear exactly where engineers intended. On August 9, 2020, that was exactly what thousands of spectators expected to see at the former Didcot Power Station in southern England. Cameras were rolling. The exclusion zone had been cleared. Every countdown suggested the massive cooling tower was about to become another textbook demolition. 3, 2, 1. A deafening blast echoed across the site as explosives ripped through the tower's lower supports. Dust surged outward, swallowing the base in a thick gray cloud. For a brief moment, the crowd waited for the enormous concrete shell to collapse. It never did. As the dust slowly cleared, an almost unbelievable sight emerged. The cooling tower was still standing, damaged but standing. Instead of collapsing into its own footprint, the towering structure had survived the initial blast, creating one of the most awkward situations a demolition team can face. A structure that had been designed to disappear in seconds had now become even more dangerous, its stability impossible to guarantee without a complete reassessment. Engineers immediately suspended further work, while specialists inspected the weakened tower. Although the explosives had severely damaged key supports, enough of the reinforced concrete structure remained intact to prevent a full collapse. The carefully planned implosion had turned into an unexpected engineering challenge. The tower was eventually brought down safely under a revised demolition plan, but the incident served as a reminder that even the most experienced demolition teams can never predict every hidden weakness or hidden strength inside an aging structure. Fortunately, this failed demolition remained inside the safety zone. The next one wasn't nearly as contained. Instead of refusing to fall, an entire building collapsed in the wrong direction, turning a carefully planned implosion into a disaster no one saw coming. Number 9. The apartment building that fell the wrong way. A controlled demolition is designed to eliminate uncertainty. Every explosive charge is calculated. Every support column is selected with precision. Every collapse is expected to follow a carefully predicted path. But sometimes gravity has other plans. As demolition crews prepared to bring down an aging apartment building, everything appeared ready. The surrounding streets had been closed, nearby buildings were protected, and spectators watched from what was believed to be a safe distance. Months of engineering had led to this single moment. The countdown began. 3, 2, 1. A series of powerful explosions raced through the lower floors, and the building immediately started to move. At first, everything looked perfect. The structure leaned exactly as planned, and a massive cloud of dust erupted around its base. Then, without warning, the collapse changed direction. Instead of folding neatly into the designated demolition zone, part of the building pivoted unexpectedly. Thousands of tons of concrete and steel shifted sideways, sending debris beyond the planned impact area and far closer to nearby structures than engineers had intended. Although the building was ultimately brought down, the unexpected movement forced emergency crews to secure the surrounding area while demolition teams inspected nearby property for damage. The incident also highlighted one of the greatest challenges in controlled demolition. Once gravity takes over, even a slight difference in how a structure breaks apart can dramatically change the direction of the collapse. Later analysis suggested that variations in the building's internal structure and the sequence of the collapse likely contributed to the unexpected movement. Older buildings are often modified over decades, and hidden reinforcements or undocumented alterations can cause a structure to behave very differently from engineering models. The demolition was completed, but it became another reminder that controlled demolition doesn't always mean completely predictable. At least this building still came down. The next demolition was even more astonishing. Engineers triggered the explosives exactly as planned, but when the dust cleared, a huge section of the structure was still standing, creating a dangerous problem that couldn't be solved with a single blast. Demolition engineers push the button. There is no easy way to stop what happens next. The explosives either do their job or they don't. As thousands of spectators gathered to watch the demolition of an aging stadium, expectations couldn't have been higher. The structure had hosted decades of sporting events, concerts, and unforgettable moments. Now, after months of planning, carefully placed explosive charges were expected to erase it from the skyline in less than 20 seconds. The countdown echoed across the site. 3, 2, 1. A rapid chain of explosions burst through the lower supports. Concrete shattered. Dust surged into the air. Within seconds, large sections of the stadium collapsed exactly as engineers had predicted. Then the dust began to settle. Something was wrong. A massive section of the stadium was still standing. Instead of disappearing in one controlled implosion, one of the largest parts of the reinforced concrete structure had survived the blast almost completely intact. While the rest of the stadium lay in ruins, the remaining section towered over the demolition site, leaving crews with a dangerous and highly unstable structure that could no longer be brought down using the original plan. Operations stopped immediately as engineers reassessed the damage. Investigators later pointed to the immense strength of the remaining reinforced concrete and the way the collapse forces had traveled through the structure. Demolition charges are designed to remove specific load-bearing elements. But if even part of the structural system remains stronger than expected, the entire collapse sequence can change in an instant. Instead of a demolition measured in seconds, crews now face days of additional work using heavy machinery and revised demolition methods. What had been planned as a textbook implosion became another reminder that even modern engineering cannot eliminate every uncertainty hidden inside massive concrete structures. The stadium eventually disappeared, but not in the spectacular way anyone had expected. Even so, the remaining structure stayed where it was supposed to. The next demolition was far more alarming. This time, it wasn't the building that caused the biggest problem. It was what happened after the explosion, when debris and dust spread far beyond the area engineers thought they had under control. Number 7. The implosion that covered an entire neighborhood in dust. A successful demolition isn't judged only by whether the building comes down. It's also judged by everything that doesn't happen afterward. No flying debris, no damage beyond the exclusion zone, and no dangerous clouds spreading into nearby communities. When demolition crews prepared to implode a large concrete building surrounded by busy city streets, every precaution had been taken. Traffic was stopped, nearby businesses were warned, and engineers had spent weeks calculating how the structure would collapse while keeping the impact contained. On demolition day, spectators lined up behind safety barriers, cameras ready. The countdown reached 0. A powerful series of explosions echoed through the city as the building folded inward almost exactly as planned. Within seconds, thousands of tons of concrete crashed into the ground, sending a towering gray cloud high into the air. At first, everything looked like a textbook implosion. Then the wind changed. Instead of settling quickly over the demolition site, the enormous dust cloud drifted far beyond the expected containment area. Streets disappeared behind thick gray haze. Nearby buildings were engulfed. Drivers slowed to a crawl as visibility dropped, while residents watched the cloud roll through surrounding neighborhoods. Although the structure itself had collapsed successfully, the demolition quickly became a reminder that bringing down a building is only part of the challenge. Managing what happens afterward can be just as important. Investigations found that weather conditions, the sheer volume of pulverized concrete, and the behavior of airborne dust all played significant roles in how far the cloud traveled. Modern demolition projects now place far greater emphasis on dust suppression systems, water cannons, weather monitoring, and carefully timed implosions to reduce the risk of similar incidents. No matter how precisely the explosives are placed, nature can still influence the final outcome in ways no engineer can completely control. For demolition professionals, the event became another valuable lesson. Sometimes the greatest danger isn't the collapse itself, it's what the collapse leaves behind. But drifting dust can eventually clear. The next demolition created a problem that couldn't simply blow away. Instead of dealing with a cloud of concrete, engineers were left facing a towering structure that threatened to collapse at any moment, forcing an entirely new battle against gravity. Number 6. The hotel that wouldn't come down. Some demolition failures happen in an instant. Others leave behind a danger that can last for days. When an aging high-rise hotel was finally scheduled for demolition, engineers expected the implosion to be one of the largest and most carefully coordinated projects in the city's recent history. Every explosive charge had been positioned to remove the building's key structural supports, allowing gravity to do the rest. For weeks, nearby streets were closed, surrounding buildings were protected, and hundreds of workers prepared for the moment the skyline would change forever. The countdown began. 3, 2, 1. A series of sharp explosions echoed through the city as the lower floors disappeared behind a massive cloud of dust. The upper levels immediately began to sink, and for a split second, it appeared the demolition was unfolding exactly as planned. Then everything stopped. As the dust slowly drifted away, an astonishing sight came into view. A large section of the hotel was still standing, damaged, leaning, but refusing to collapse. Instead of ending the operation, the implosion had created a far more dangerous situation. The remaining structure had become unstable, with no way of knowing exactly how long it could stay upright or what might trigger the final collapse. Engineers immediately expanded the exclusion zone, while structural specialists evaluated the risks of sending crews back into the area. Later assessments suggested that parts of the reinforced concrete frame had remained stronger than expected, preventing the progressive collapse from continuing through the entire building. In controlled demolitions, every structural element must fail in a carefully timed sequence. If even one critical section survives longer than anticipated, the entire collapse can stall, leaving behind an unpredictable shell of damaged concrete and steel. Heavy equipment was eventually brought in to dismantle the remaining structure piece by piece, a process that took far longer than the demolition originally planned to last. The failed implosion became another reminder that in demolition engineering, bringing a building halfway down can be far more dangerous than not bringing it down at all. But even an unstable building can eventually be dismantled with enough time and machinery. The next demolition offered no such second chance. In just a few seconds, a towering structure fell in the wrong direction, showing how a single miscalculation can change everything before. Number 5. The chimney that fell the wrong way. A demolition can be over in less than 10 seconds. But if a structure starts falling in the wrong direction, there is almost nothing anyone can do to stop it. That was the terrifying reality during the demolition of a towering industrial chimney. Standing high above the surrounding landscape, the aging concrete structure had dominated the site for decades. Engineers carefully studied its condition, calculated the direction of collapse, and positioned explosive charges around its base with one goal in mind: bring the chimney down safely into a designated landing zone. Everything depended on gravity following the plan. The countdown echoed across the demolition site. 3, 2, 1. A powerful blast ripped through the lower section of the chimney. For an instant, the massive concrete tower seemed to hesitate before slowly beginning to lean. At first, it appeared to be falling exactly where it should. Then the angle changed. Instead of continuing toward the planned impact area, the towering chimney unexpectedly rotated and began falling in a different direction. Thousands of tons of reinforced concrete crashed to the ground outside the intended collapse path, sending debris much farther than expected and forcing emergency crews to immediately secure the surrounding area. Although the exact reasons varied according to engineering assessments, experts pointed to a combination of structural imbalance, uneven failure of key supports, and the unpredictable behavior of aging reinforced concrete. In demolition work, even a slight difference in how the base fractures can dramatically change the center of gravity, causing an entire structure to pivot in an unexpected direction. Fortunately, incidents like this are rare, but they demonstrate why demolition planning involves extensive safety zones and why experienced engineers never assume a structure will behave perfectly. Once gravity takes control, correcting the collapse is no longer an option. The chimney eventually came down completely, but the unexpected change in direction became another reminder that precision on paper doesn't always guarantee precision in the real world. But at least this collapse happened out in the open, where crews had room to react. The next demolition took place in a far tighter environment, where a single mistake threatened nearby buildings and turned what should have been a routine implosion into an engineering crisis. Number 4. The high-rise demolition that threatened the buildings next door. In open spaces, a demolition has room for error. In the middle of a city, even a few extra feet can become a serious problem. That challenge faced engineers preparing to demolish a high-rise surrounded by offices, apartment buildings, and busy streets. Every detail had been planned months in advance. Structural surveys were completed, explosives were installed with precision, and computer models predicted the building would collapse neatly into its own footprint without touching the neighboring properties. Everything depended on those calculations being right. As spectators watched from behind the exclusion barriers, the countdown began. 3, 2, 1. A rapid series of explosions echoed through the lower floors. The building immediately started to sink as columns failed one after another. Huge clouds of dust burst outward, and for a moment, it looked like another perfectly executed implosion. Then the upper floors began to twist. Instead of dropping straight down, part of the structure leaned toward the neighboring buildings. Massive sections of concrete broke away from the main collapse, scattering debris far closer to surrounding structures than engineers had intended. Emergency crews immediately moved to inspect nearby buildings, while demolition teams confirmed that no additional sections were at risk of falling. Fortunately, the neighboring buildings remained standing, but the incident demonstrated just how unforgiving urban demolitions can be. Unlike isolated industrial sites, city projects leave almost no margin for error. A slight change in how a structure fractures, an unexpected reinforcement hidden inside the building, or an uneven collapse sequence can alter the direction of thousands of tons of concrete within seconds. The investigation that followed reinforced an important lesson for the demolition industry. Predicting how a building should fall is one thing. Predicting exactly how decades of aging concrete and steel will behave under explosive forces is something else entirely. The building was eventually cleared, but the event became another reminder that the closer a demolition is to surrounding structures, the greater the consequences of even the smallest miscalculation. Yet this building still collapsed mostly within the planned area. The next demolition was even harder to believe. The explosives worked, the structure came down, but one enormous section refused to break apart, leaving crews with a dangerous obstacle that couldn't simply be ignored. Number 3. The bridge that refused to break. Bringing down a bridge isn't just about making it collapse. It's about making every section collapse exactly when it's supposed to. If even one critical span survives, the entire demolition can become far more dangerous than anyone anticipated. That was the challenge engineers faced when an aging concrete bridge reached the end of its service life. After carrying traffic for decades, it was finally scheduled for demolition to make way for a modern replacement. Weeks of preparation went into the project. Explosive charges were carefully installed at key structural points. Nearby roads were closed, and engineers calculated how each section would fall in a precise sequence. Everything pointed toward a clean implosion. The countdown began. 3, 2, 1. A powerful series of explosions ripped through the bridge's support columns. Dust and debris burst into the air as parts of the structure immediately gave way. Huge sections crashed into the ground exactly where demolition crews expected. Then the collapse stopped. As the dust cleared, one of the bridge's largest spans was still hanging in place. Cracked, twisted, but refusing to fall. The surviving section created an immediate safety concern. Although badly damaged, it still weighed thousands of tons and could no longer be trusted to remain stable. Engineers expanded the exclusion zone, while structural experts assessed whether the remaining span might collapse unexpectedly or require a completely different demolition strategy. Investigators later concluded that portions of the bridge had retained more structural strength than anticipated. Reinforced concrete, hidden steel members, and the way forces were redistributed after the initial blast prevented the collapse from progressing through the entire structure. Instead of one controlled demolition lasting only seconds, crews spent days removing the remaining span using heavy machinery and specialized equipment. The incident became another reminder that even when explosives perform exactly as designed, the structure itself may still behave in unexpected ways. In demolition engineering, every surviving section creates new risks that must be managed with patience rather than speed. But at least the remaining bridge stayed where it was. The next demolition left no time for careful planning afterward. Within seconds, an enormous structure collapsed with devastating consequences. Number 2, the Royal Canberra Hospital implosion that went terribly wrong. Australia, 1997. For every controlled demolition, one rule stands above all others. No one outside the exclusion zone should ever be in danger. On July 13, 1997, thousands of people gathered around the shores of Lake Burley-Griffin in Canberra, Australia, to witness the demolition of the former Royal Canberra Hospital. It had been promoted as one of the largest public implosions the city had ever seen, attracting families, photographers, and spectators eager to watch decades of history disappear in a matter of seconds. Months of preparation had gone into the project. Engineers carefully positioned explosive charges throughout the building, established exclusion zones, and planned every stage of the collapse. By all accounts, the demolition was expected to proceed safely. The countdown began. 3, 2, 1. A thunderous explosion echoed across the lake as the hospital's lower supports gave way. Within moments, the massive structure folded inward, sending thousands of tons of concrete crashing to the ground. For an instant, everything appeared to be unfolding exactly as planned. Then came the unexpected. Instead of remaining inside the demolition zone, fragments of concrete and debris were launched far beyond the predicted area. Some pieces traveled hundreds of meters through the air, shocking both spectators and emergency personnel. What had started as a carefully planned engineering operation suddenly became a major emergency response. The tragedy prompted multiple investigations into the planning, blast design, and safety arrangements surrounding the demolition. The findings led to significant changes in how large public implosions are managed, including stricter exclusion zones, more conservative safety calculations, and tighter control over public access during demolition events. For demolition engineers around the world, the Royal Canberra Hospital implosion became a lasting reminder that even when a building collapses as intended, the forces released during an explosion can still produce consequences far beyond computer models if every risk is not fully accounted for. It remains one of the most widely studied demolition incidents in modern engineering history. But even this disaster wasn't the most astonishing demolition ever captured on camera. At number one is a demolition that completely defied expectations. A structure so unbelievably strong that what happened after the explosives detonated left engineers around the world asking the same question: how was it still standing? Number one, the cooling tower that survived the explosion. Every controlled demolition is built around one assumption. If the explosives destroy the right supports at exactly the right moment, gravity will finish the job. But every so often, gravity refuses. That was the unbelievable scene during one of the most talked about demolition failures in recent years at the former Didcot power station in England. After decades dominating the skyline, one of the site's enormous reinforced concrete cooling towers was finally scheduled for demolition. Engineers spent months surveying the structure, calculating the explosive charges, and modeling exactly how thousands of tons of concrete would collapse safely into a carefully prepared exclusion zone. By demolition standards, it was supposed to be routine. As spectators gathered with cameras pointed toward the towering structure, the countdown echoed across the site. 3, 2, 1. The explosives detonated with a deafening roar. Powerful shock waves ripped through the tower's lower supports, and a massive cloud of dust exploded outward. For a few seconds, almost everyone expected the familiar sight of a cooling tower folding inward before disappearing into a mountain of concrete. Instead, the tower simply stayed where it was. As the dust slowly drifted away, the enormous concrete shell still dominated the skyline. Scarred, damaged, but remarkably still standing. The failed implosion immediately transformed a planned demolition into a far more complicated engineering problem. Although critical sections of the base had been destroyed, enough of the tower's reinforced concrete structure remained intact to prevent a complete collapse. What should have been a structure safely lying on the ground had become an unstable giant that could no longer be trusted. Engineers suspended operations at once and began a detailed structural assessment. With the tower partially damaged, sending workers too close carried obvious risks, while attempting another explosive demolition without understanding the remaining load paths could make the situation even more dangerous. Investigations suggested that the immense strength of the reinforced concrete, combined with the way the remaining structural forces redistributed after the initial blast, allowed the shell to resist total collapse. It was a powerful reminder that even the most advanced computer models cannot perfectly predict how decades-old structures will behave once explosive forces are unleashed. Eventually, demolition crews developed a revised strategy, and the cooling tower was safely brought down. But the first attempt became one of the clearest modern examples of how even carefully engineered implosions can produce completely unexpected results. It is easy to think of demolition as controlled destruction, yet the truth is far more complicated. Every implosion is a battle between engineering, physics, and thousands of tons of aging concrete. Most of the time, the calculations win. Sometimes, the structure has one last surprise waiting, and those rare moments are exactly why demolition remains one of the most challenging and fascinating disciplines in engineering. From buildings that refuse to collapse, to structures that fell in completely unexpected ways. Every demolition in this countdown proved one thing: even the most carefully planned engineering projects can still produce surprises. Behind every controlled implosion are months of calculations, detailed structural analysis, and highly experienced demolition teams. Yet once the explosives detonate and gravity takes over, there are no second chances. If you enjoyed this countdown, which demolition surprised you the most? Let us know in the comments below. We'd love to hear your thoughts. And if you enjoy real engineering, incredible construction projects, and fascinating true stories caught on camera, don't forget to like this video, subscribe to the channel, and turn on notifications so you never miss our next Top 10 documentary. Thanks for watching, and we'll see you in the next video.